Okay, so for this question, this is what? This is number, it's in the section 1.4 in WebAssign. I mean, Math, I believe. It's also very similar, just so you know, it's very similar to um, number 32 also. It's a little different in 32 because in number 32, they're giving you this, the time to find the bacteria after 32 hours. So that means you take 4 and you substitute it into the temperature formula because that's the temperature based on time. Here, let me get the pointer going. I'm not sure, totally sure you can see my mouse. Okay, so you're going to take 4 for this one in the textbook. You're going to take 4, substitute it in here for in the temperature based on time function. You'll get a temperature. Take that value, substitute it into the number of bacteria temperature function. Solve that. Okay, now this one in MyOpenMath is asking you a little differently. First off, to make MyOpenMath happy with this question is what you're going to do with you're going to nest, you're going to compose, substitute that in for big T, because that's the function that's, big T is the temperature, and this is the function that makes temperature based on time. And that's what you get here. And I wouldn't try to clean that up. I just leave it the way it is. I've tried to get WebAssign to take it before, or MyOpenMath to take it before, and it just doesn't like the simplification. So it does accept that though. Then for part 2, it says find the time when the bacteria reaches the value. See, before it was they gave us a time, find the bacteria. Now we're going to work backwards. That's a little bit more difficult question. So what we're trying to really do is, right, this other function says here's the bacteria equals this expression where temperature is the variable, the independent variable. So that's what we got to do is work backwards to find the time. So that's the number of bacteria. Now, this is a quadratic equation, and normally what we do with quadratic equations is we set them equal to 0, and you're going to be doing this in chapter 3. So it's probably not very fair of me to do this, but it isn't like this is the first time you've seen quadratic equations, so I don't feel too guilty. So what we would do to do this by hand, it would subtract that 26,000 number, set it equal to 0, then probably use a quadratic formula. Okay. What I would do, because the point of this question is not to practice the quadratic formula, but to work with composite functions, I recommend you use some technology to solve this. And one that I've been using that I like quite a bit is, let's see, where is that? Let me find it here. Come on. I don't want to do that. I don't want to do that. I want to be able to see my windows here. Here it is. Symbolab works really well. My students at Oxbow got me into using this website. I also have other versions. I've got a calculator on my phone that I use quite often. And my TI calculator also has a quadratic equation solver. But Symbolab is pretty cool because it works for any polynomial. So I just type that right in. I click go, and it doesn't show me all the steps. So I think you can click on show steps. Oh yeah, here's the steps. What did it do? Yeah, see, then they used the quadratic formula and they did all that simplification. Not a very pretty thing. So then we get these two answers. Now let me scroll over so we can see this. And I see a positive answer and I see a negative answer. And that makes sense. Parabolas, they look like U's. They cross the x-axis twice often. And this function crosses at a negative value, which is negative time, which doesn't make any sense. And then this is so these are temperatures, not times. I'm sorry. These are temperatures. So at negative 29, well, at negative 29 degrees, bacteria don't grow too quickly. So we know that's kind of a crazy value, but that's the one we're looking for. So 34.74, let's see. So here's what we're going to do. So now what I'm going to do is, just so you know, here, let me come back over here. What at 30, I'm going to write 34.7, but I'm not going to use that. I'm going to come back and use the unrounded thing because I'm trying to keep this computer happy. So, but now what I'm going to do is, this is the temperature we just solved for. So the 34 point, I'm not sure I'm recording. Am I? Yeah, I am. Good. Woo. 34. Haven't had any coffee yet this morning, so that's one reason I'm saying this. So 34.7 it is. and 7t plus 1.6. Now I solve this equation, and that'll give me the time. So if I subtract those, I don't even want to try to do this in my head. Though I guess I can. What's 34.7 minus 1.6? I think it's 33.1 equals 7t. And then I divide by 7. And that one I don't want to do in my head. Let's see. 33.1 divided by 7. I'm getting... is this hours? Yes. Okay. 4.7 hours. Now I'm not sure I have enough decimal places to make MyOpenMath happy with this. So what I probably will do is come right back here to Symbolab. Let's see, the function is 7t plus 1.6. I mean, I could just do it with a calculator, but since I get Symbolab open, I'm going to clear this. Let's see, 34 point. Boy, will it let me remember this stuff? No, I can't copy paste, can I? So I'm just going to say, I'm going to do that right here. 34.7447. That's probably enough to keep Symbolab happy. Equals 7t plus 1.6, right? 1.6 Dan. And hopefully that's right. And then lo and behold, hopefully it gives us some answers. Shows us the steps. It shows you 4.73. So that's what MyOpenMath would be looking for. 4.73, and I got 4.7. So, all right. So that's how you do that question. Hopefully that helps. Okay. I guess I'll stop this video.